Welcome back to our geometry series. We're up to section 1.2, and we'll be talking about postulates and theorems related to points, lines, and planes. Statements accepted as true are called axioms or postulates. These are used to justify further conclusions. Later in geometry, we will be talking about proofs, where we'll use postulates and theorems to prove a statement to be true or false. Postulate number 1. A line contains at least two distinct points. A plane contains at least three non-collinear points. Space contains at least four non-coplanar points. What this is really doing is just redefining a line, a plane, and space, or volume, for a 3D shape. Here's a figure. We have line K, curve M, points R and S. Straightness is a property of a line, so K is the only line in this drawing, and the only line that contains both R and S. Postulate 2. If two distinct points are given, then a unique line contains them. In other words, two distinct points determine a unique line. Postulate 3. Through any two points there are infinitely many planes. Through any three points there is at least one plane. Through any three non-collinear points there is exactly one plane. Here's our 3D rendering of two planes, 3 points, and one line. Two distinct points, A and B, are given, then there's a unique line shown in black here. Through any 2 points there are infinitely many planes. The red plane and the blue plane both go through A and B. If you can imagine, any number of planes could be created that rotate around those 2 points. Through any 3 points there's at least one plane. Through any 3 non-collinear points there's exactly one plane. So those 3 non-collinear points, all not on the same line, are A, B, and C that create exactly the one plane, the blue plane shown here. Postulate 4. If 2 points are in a plane, then the line that contains those points lies entirely on the plane. Postulate 5. If two distinct planes intersect, then their intersection is a line. Looking back at the same 3D image, 2 points are in a plane, A and B, they're in the red plane, then the line that contains those points lies entirely on the plane. So the line, AB, is in the same plane as those points. And if two distinct planes intersect, then their intersection is a line. So here, the blue plane and the red plane intersect, and where they intersect, it is a line, shown in black. Statements that must be proven true by citing undefined terms, definitions, and/or postulates are called theorems. Theorem number 1. If two distinct lines intersect, then they intersect in exactly one point. Here's our friend, line PQ that we've seen before, and line M, intersecting at point R. We have two distinct lines that are unique and different. They intersect, and they intersect in exactly one point. In this case, it's point R. Theorem 2. If there is a line and a point not in the line, then there's exactly one plane that contains them both. In this 3D image, we have a blue plane, and we have a line, and a point that is not on the line. So if there's a line and a point not in the line, then there's exactly one plane that contains everything. That would be this blue plane here. Theorem 3. If two distinct lines intersect, then they lie on exactly one plane. Here, we've created a line BC, connecting the 2 points B and C. So we have two lines that intersect. They intersect at point B, and these two lines intersect in exactly one plane, the blue plane shown here. A postulate is accepted without proof, but a theorem must be proven. We're going to jump over some 3D examples. Below is the website that I'm using to create these models. At the end of the lesson today, I'll show how I created the various planes and lines and such. So over here at Math 10, I'm going to create a point A. There it is. And a point B. There it is. And we'll draw a line. Through any 2 points, there is exactly one line. Now this particular website doesn't show the arrows on the end of the line, but this is a line drawn that goes on forever. Let's add a third point, point C. That's over here. So we have 3 points that are non-collinear, so we can create a unique plane. So now we have a plane, A, B, and C, or I'll just call it the blue plane. And this allows you to rotate and flip it around, and you can look at it at different angles. So now we have a plane, the blue plane, created by A, B, and C. Now let's throw another plane on here. Why? This looks similar. This is what we had in the slides. Through points A and B, I've created 2 planes, but you can imagine we could create any number of planes that slice through points A and B. The red plane and the blue plane intersect at exactly one feature. That's the line AB shown here. We can add a third plane. Again, any number of planes could be created through 2 points. Next, let's add a line between points C and B. Now we have a line between C and B. We have line AB and line BC intersecting at point B. Because we have 2 lines that intersect at exactly 1 point, there's exactly 1 plane that contains both lines. That would be the blue plane in this example. And that's it for the new material. If you'd like to stick around, I'm going to clear this off and start from scratch to show you how to use this website. So this is what the website looks like when you start. It has an X, Y, and Z axis shown. This can be turned off with this feature, the view with nothing. Right now, let's start with the axis being shown. Up here, you can create a point. I want to create a point. It allows you to put it anywhere on the X, Y plane, or you can pick a point on an axis. So let's start with here. This shows you the 3-dimensional coordinates, X, Y, and Z. So it's X equal to 3. I will put one also on the Y-axis and one way up here on the Z-axis. Now we have 3 points, A, B, and C. These can be turned off if you don't want to look at them. So now we can create a plane. Click here, plane through 3 points. So you could pick these 3. You can pick 3 points. And it creates this angled plane through this. If you want to rotate, you go back to the arrow. So now you can look at the plane you've created. You can also create a plane using the axes that are here. Pick 3 points. You can just pick the points on the axes and create a plane like this. So now we have a plane intersecting the other plane we created. If you want to get fancy, you can click on an item, go to settings, and you could change the name, you could change the color, get a nice red or purple plane. And once you've created the items you want, you can close this, click over here somewhere, and this item comes back, and you can turn off all the axes, and you're left with just the points that you've created. You can also create lines. Line. Down at the bottom it says select 2 points or positions. I can pick this point, and it'll move around until you click, so you can pick which one you want. You can pick C. And let's do that again with B and C. Now we have 2 lines. Oh, need to move. Click the arrow. We have 2 lines that intersect at 1 point, C. So those 2 points, or these 2 lines, must exist on the kind of pink plane that we have here. So play around with this a little bit. It's a fun little tool, and we will probably be using it quite a bit. And that's it for today. We'll see you next time.